Hello and welcome to this lesson on the properties of parallelograms. Our essential question and objectives for this lesson are what are specific properties of parallelograms, and so we're going to list the properties of parallelograms and the theorems that go along with it. Standards: use congruence and similarity criteria for triangles to solve problems and to prove relationships in geometric figures, and prove theorems about parallelograms. A parallelogram is a quadrilateral with both pairs of opposite sides parallel to each other. In a quadrilateral, opposite sides do not share a vertex, and opposite angles do not share a side. So here are the four properties of a parallelogram that are very important when talking about parallelograms. So I would highly suggest that you either pause this video or you intently listen and take notes. It is very important. Take notes. Write these four theorems down. They're going to be very important, and they will definitely be used later in your homework assignments and or quizzes and or tests to prove congruence either with triangles within a parallelogram or just congruence of parallelograms in general. So definitely write these down. Remember, you can always pause the video to do that. The following are the important theorems to know when talking about improving congruence in parallelograms. The first one: if a quadrilateral is a parallelogram, then the opposite sides are congruent. If a quadrilateral is a parallelogram, then its consecutive angles are supplementary. Now remember, supplementary means that the angles add to 180 degrees. The third one: if a quadrilateral is a parallelogram, then its opposite angles are congruent. So opposite sides and opposite angles are congruent. And most importantly, if a quadrilateral is a parallelogram, then its diagonals bisect each other. So let's just look at those four theorems that we just talked about. The first one says the opposite sides are congruent. So for this parallelogram, that would mean that DC, and remember these arrows right here, they just mean that they're parallel, that they have the same number of arrows. So AB is parallel to DC. Write that up here just so we don't forget. AB is parallel to DC, and AD is parallel to BC. Since the opposite sides, AB and DC, AD and BC, are parallel, then it is in fact a parallelogram. And since it is a parallelogram, our first theorem says that opposite sides are congruent. So AB is congruent to DC. AB is congruent to DC. Don't forget my lines when I'm talking about segments. All right, and since AD and BC are opposite sides as well, that means that AD is congruent to BC. Now it also says that consecutive angles are supplementary, which means angle D and angle C are supplementary. Angle D and angle A are supplementary. A and B are supplementary. B and C are supplementary. So as long as the angles are next to each other, A and D or D and C, those are the two angles, they are supplementary. So D and C are supplementary. D and A are supplementary. A and B are supplementary. B and C are supplementary. And I believe that's it, because if I write others, then they'll just repeat. So those are all supplementary angles. Now the third theorem says that opposite angles, so D and B, are congruent. So angle D is congruent to angle B, and also A and C would be congruent. So angle A is congruent to angle C. And last but not least, let me change my ink color on this, is that the diagonals of the parallelogram are also congruent and they bisect each other. So let's say they bisect each other at point E. That means AE is congruent to EC and DE is congruent to EB. That's the big one. So the last theorem says that AC, so that's one of the diagonals, and BD, that's the other diagonal, bisect each other. So therefore, AE is congruent to EC, that's where they meet, at E, and DE is congruent. DE is congruent to EB. Now here's an example where you might have to use the properties that we just discussed to kind of conclude an answer. So it's asking, what is angle P? So the measure of angle P, that's what that M means. What is the measure of angle P and PQRS, which is this parallelogram right here. Now we see that S is 64. So how is angle P related to angle S? Well, they're consecutive. So we're going to use the property that consecutive angles are supplementary if the quadrilateral is a parallelogram, and it's given to us that it is. So that means that the measure of angle P plus the measure of angle S must equal 180 degrees. So therefore, the measure of angle P plus the measure of angle S, which is 64, which it gives us 64 degrees equals 180 degrees. So if I subtract 64 degrees from both sides, I will get that the measure of angle P is equal to 126 degrees, which would give us D, would be our answer. Here's a view of your homework. You start off with reviewing vocabulary. What are supplementary angles? What do they sum to? And then just different examples of using supplementary angles. Vocabulary builder, you're talking about consecutive, what exactly that means, and then you're going to use that that term consecutive to make conclusions about another shape, and then you're going to use the theorems and properties that we talked about in the lesson to answer questions about certain problems and examples. So if you have any questions, feel free to reach out to me, BBIM, text message, email, phone call, whatever's easiest for you. Meet me in live class where we can discuss this a little more. You can ask questions. Meet me in the Math Cafe Monday, Tuesday, and Wednesday at 11 a.m. Or if that doesn't fit your schedule, go into the Math Cafe at any time between 9 and 3, Monday through Friday. There's a teacher in there that is willing to help you on your math homework or assignments or anything you have questions on. So be sure to give this a try, and we'll see you in live class.